the light thing again. Oh, Jacob, will you hit the third button down, please? Need money. Thank you. All right. Let's see where we left off last time. Okay, and I think didn't I download Unity in class last time, and I'm pretty sure it finally did finish. Unity, it's F1. Yeah, this is the newest one. So we'll open that 2.5. Yeah, let me get rid of this link. All right, so I have the newest Unity here. So for us, has everybody gone and purchased the video dealy flippy thing? Is it $10 or was it less than $10 if you were first time? $10. Okay. So everybody has that. We'll start looking at that before too long. I want to talk about some stuff first. Okay, so we talked about in game design, there's kind of multiple categories of proficiencies, and depending on whether we're like an indie developer. So those of you who've played like, or on PlayStation or Xbox Live or something like that, and you go and look at games, you have a bunch of like free games on there or $1.99 games that are made by independent developers, indie developers, which might be one person or a team of 2 or 3 buddies, something like that. A lot of times teams like that might have more of a cross-training skill set where everybody kind of can code, everybody can kind of design and that kind of stuff, where in the professional game industry, you're probably going to have folks who are very much programmers who at least know enough about what happens in the design side of things in order for them to know what they have to give them to get the right output from them. All right, so at the high level, you kind of have these 3 different folks. You have other project managers and stuff like that mixed in there, but we're focusing on this programming side of things. So as we go through our game design stuff in here, we will be using existing assets when we go to try to make something look good. And before that, we'll be just using the primitive types that are built into Unity, where we'll have like a cube that runs around the world and stuff like that. Okay, so that's what we were talking about here. We talked about what a game engine provides. So when we are, even as a game programmer, we still want to focus on delivering the actual game in terms of, the implementing the level that has been designed, getting your characters on the screen, programming the movement. So dudes jumping around, things like that. If we have an enemy that we want to kind of wander around a scene or something, that's something we want to program, but we want to leverage the tool. So we're going to be using Unity, which has a whole bunch of stuff geared for game design for doing that stuff, as opposed to us going and writing all the little tiny math for, like, I think I probably mentioned last time, like there's a pathing algorithm called the A-star algorithm, which really cool algorithm that very well might be what Unity's using under the hood for making dude go from here to here, not bumping into cabins and stuff like that. But what's nice about Unity is we don't have to write that. We just have to implement the 2 or 3 little layers that are important for their built-in tool to work. All right, same thing with animations. We bring things in that are already pre-rigged, pre-animated, and then we just say which animation we want to play at different times. So if somebody hits button 1, which says attack dude, behind the scenes, we'll write the script that says play the swing sword animation. Make sense? Somebody else already created that specific animation. We're not going to be creating frame by frame sword swinging through the air. That's already created for us. We're just telling it to play that animation. So ultimately, what it comes down to for us is we're going to have two complementary skill sets in here. One is we're going to be learning the tool that is Unity 3D, which is, I think it's fair to call it an industry standard now for game design. If you go to, I think I probably mentioned at the end of class last time, I mean, if you're working for like a Blizzard Activision or Electronic Arts or something, the AAA game developers, they likely have their own internal game engine. They've been evolving over the years. So they're not specifically using Unity, but Unity would be kind of, let's call it the public version of that. It's definitely a tool that indie developers are using. And it's also the tool that startup companies that are not just indie developers. You might have a team of 100 people working on a game that isn't some gaming company that's been around for 20 years. They would start using a tool like either Unity, so are kind of our two competitors today. Would be Unity. And the other one is Unreal Engine. All right, there's some lesser known ones in the middle, but these are our big two. If you look at any indie game you download on either PC or Xbox or PlayStation, a high percentage of them will either have a Unity logo at the beginning of it or an Unreal Engine logo at the beginning of it. And if you don't see that logo at the beginning of it, that doesn't mean they're not using one of those engines. That means they're probably a bigger company that doesn't want to reveal what their underlying thing is. So they're paying for the top dollar for that game engine so that they don't have to use the game engine's logo. Kind of make sense? If you're a game developer and you want to use kind of the normal pro version of Unity, you're paying $200 a year or something like that for it. They give you all their pro tools and stuff. But when you publish a game, A, it'll have the Unity logo as an initial splash screen. And B, your game gets up to, I think it's, I don't know, remember what the exact number is, but it's something like 200,000 in revenue or something like that before you have to start giving Unity a cut. Unity then has a higher level, like an enterprise one, where you can give them a lot more than $200 a year. You don't have to use their logo. You never have to give them a cut of your revenue. There's like a trade-off. So if you're an indie developer and you're not expecting that you created the next Angry Birds, you're probably going to go with the $200 a year thing. You're going to see that splash screen. How many of you have seen either Unity or Unreal Engine splash screen before? Several different. Have you seen both of them? All right. So these are our two competitors. So why Unity? When Unreal Engine first came out, it was kind of considered the super cool kid. This was from a AAA developer, so it was a really highly respected game engine for years and years. They were internally licensing it to other companies for them to use. So they released it to the public, so anybody could use Unreal Engine, and then people started making games with it. It's good. Nothing wrong with it. In fact, for a long time, Unreal Engine was considered to be graphically superior to Unity. Unity in its latest versions, really since 2017's Unity, they've played catch up there. And they're probably kind of equal to Unreal Engine in terms of graphics realism, when you have like blades of grass kind of flowing back and forth, that kind of stuff. So it's not as clear cut, at least, the difference between those two. What you have now is a much, much, much bigger and faster growing community with Unity of indie developers as well as assets. Unity's maybe their greatest strength is they have their own built-in asset store, which is kind of like, either Google Play or the Apple App Store in your phones, where like, hey, I need a paladin character type, or I need a little monster guy. And you can go on there and shop for that. And, if you're, us, you'll click the little filter that says free. And then it shows you all of the free monsters you can get. Or sometimes what you'll find on there is they'll have like a pack of assets that you could buy for $20, let's say, but they have a free version where you can get like one of their dudes. So you can kind of get a feel for what they're including, animations, and then you just use that dude for all your monsters. So you get a free version of something pretty good quality. But that makes it maybe a little bit more integrated. Something else that maybe really benefits Unity, whether you're a Microsoft fan or not, is Microsoft and Unity are kind of in a partnership. I don't think Microsoft owns Unity yet, but that might be something that's coming. Microsoft's been in a acquiring mood lately. We'll see how it plays out in the next probably year or so. With how many of you have heard of GitHub? Several of you have had my classes before. We've used it. We'll be using it in here. We'll be using it in 250. Really, most of my classes will use GitHub. So GitHub is a website that creates a remote repository storage location for Git repositories, GIT repositories. Now, a Git repository has been a technology that's been around for forever. A long time. And this is a source control thing where, hey, I'm a developer and I'm working with a team of 5 or 6 other guys and we're all working on the same project. You check the project out, you change the crap in the little part of the project that you're working on. You say, okay, everything seems to work. You commit it, you push those changes back out. When your buddy next works, he checks it out. He has your changes. And as he's working on his stuff, probably in a different part of the project, he can determine whether you've broken his stuff or at least write his stuff in terms of yours. So it's a management tool for people to collaborate with programming. Now, in most of our classes here, we get used to using the tool, but it's more of an independent thing where you're using it for effectively cloud storage for your code and also an easy way for you to submit assignments to me so that I can, not have to download a zip folder, unzip it, open it up. I could actually just view it all from a web page thing and see all your source code and stuff like that. But it also keeps various iterations of each file. So if you have broken your project worked last week, you've done something to file X and it no longer is a thing anymore, you can roll back to a previous version of that file and at least be at a better starting point than you were. So Git is the underlying technology. GitHub is one of several websites. It's the most popular for managing remote Git repositories. And Microsoft acquired them last year, so we will see what happens with that. They've become a pretty big deal in the development community, and we'll see if Microsoft breaks it or not. But in any case, Unity is in partnership with Microsoft. So now Unity ships, if you're downloading it for Windows, it ships with Visual Studio 2017. If you're on a Mac, when you download it, it will install Mono Develop, which is if you're on a Mac and you, so just quickly here just to talk about that. I mentioned, well, actually, let's just go back to the scripting thing. I mentioned our scripting language we're going to be using is C#. Okay, and C# is one of the .NET languages. So it's a Microsoft language. Now, they didn't need to have a partnership with Microsoft in order to use this language. So initially, before they had their connection, Unity on both PC and Mac shipped with a project called Mono Develop. Now, Mono Develop is an open source project that's been around for a while, a bunch of years. So really it comes down to, well, its existence was mostly for the Mac and Linux community. Just since it was written to be open source, they also had a PC version of it. I'm not sure who would actually use the PC version of it unless you were working on a project that was going to be compatible with all the different platforms. But when we talk about .NET, really this goes back to our old story of Microsoft trying to steal Java. So when Microsoft tried to steal Java back in the day and got sued by Sun Microsystems, now Oracle, Microsoft was then forced to come out with their own language, which that was where C# was born. Well, one of the, so many of you have had Java class before. What's one of the biggest perks of Java? Perks. What would you say about if you were describing the Java language to somebody in terms of features? What might you say about Java?
Runs with the Java virtual machine.
Okay, that's which implies what? So if it's running in a virtual machine, what can you do with it? Cross-platform. So platform independent, write once, run anywhere. So one of the benefits of Java in the, this is the thing they really pushed on in the early days. It's something that isn't really talked about much anymore because it has a benefit, but it's situationally beneficial. But with Java, you write your project once, and then it will run on any operating system that has the Java virtual machine. All right. And you're doing that then at the cost of a performance hit, because your program is running on a piece of software called the virtual machine, which is then converting it to the native thing for that platform. So you got a little dude in the middle who's taking some of that performance away by doing that conversion in real time. Okay, but from a developer's perspective, specifically for business applications, that made a lot of sense. So as a business application developer, where nobody's ever bragging that Microsoft Word, they have a Microsoft Word running at 130 frames a second, right? We should start that, because in the gaming world, right? If I'm assuming most of you are gamers at some level, one of the things you brag about is, at least on PC gaming, is frame rate. I have the latest, greatest $1,200 graphics card, and I'm getting, 320 frames per second on last year's greatest game, even though you can't see that many frames per second. I'm getting it, kind of indicating that your machine is better than the other guy's machine. And until recently, that wouldn't really be a thing on our consoles because all Xboxes were the same, all PlayStations were the same. Now that's less of a truth where, now you have like the PlayStation Pro, which kind of sort of came out for their VR stuff, which has been somewhat lackluster. But regardless, now not all PlayStations are created equal. And I think the same thing's true with the latest Xbox One. I think it has an improved graphics system as well. But still, one of the things that gamers measure their rig's performance is through frames per second. Well, we don't talk about that in business applications, right? It's not an important thing. As long as we're getting 30 frames per second, it's good enough for what we're doing. So Java was really, really, really good at writing business applications, and that was a very important aspect of that whole platform independence thing, because now somebody can write a single application and it become cross-platform. Mostly Mac and Windows is the people that really cared about it. The Linux folks were not that loud of a screaming voice. The Mac folks weren't that big of a screaming voice, but they were a pretty loud screaming voice. But in any case, Microsoft had to come out with their own version of this, and they came out with a .NET component architecture, and they said something along the lines, they said it's also platform independent. Remember, this is back in the day when that buzz phrase, platform independence, was a big deal. It's not so much talked about anymore. But the .NET component architecture was platform independent and will run on any platform as long as it's Windows. Well, technically, Microsoft could write the .NET component architecture for Mac. They could write the .NET component architecture for Linux. It's a proprietary thing. It's not an open source project, but they could port it to those other platforms, and then your .NET stuff would run on any of those platforms natively. But they didn't, although they are doing it now. They're starting to do it at this point. But for a long time, they didn't. So hence was born this mono developed project. which tried to mimic the .NET component architecture on other platforms like Mac and Linux. Since it wasn't open source, they had to effectively look at .NET and say, .NET is effectively a collection of APIs. So it's a collection of a whole bunch of little functions that allow you to do things related to the operating system, mostly dealing with gaming, but not all dealing with gaming. The unique stuff at least. So what Mono did is they went through and they tried to identify all those little things and mimic their functionality. Implementation might not have been identical, performance might not have been identical, but at least if you called this function in Mono and you called the function with the same name and the same parameters and the same output in .NET, it would produce the equivalent result, regardless of how it got that result. So they were kind of reverse engineering .NET without having access to .NET source code. Make sense? Doing it themselves. So that's where Mono Develop came from. And, over the years, they were getting, more and more of .NET ported. I don't know what percentage of it they have now because it's a moving target. Every year or every 6 months, kind of a new version of .NET comes out where they might change some old stuff or add some new stuff, whatever it is. So I'm sure it's not completely equivalent, but they've done an all right job. So Mono Develop came out as effectively an alternative to Visual Studio, which is Microsoft's programming interface, programming IDE for Windows. It came out as an alternative for that for Mac and for Linux, and you could also get it for PC if you were a gamer who was forced to run Windows, but you weren't a Microsoft fan. Kind of an open sourcey type of person. But in any case, Unity shipped with Mono Develop for a long time. Now, what's interesting about this is the only aspect of it that's really important for us as a Unity developer was that Mono Develop comes with an IDE, so an integrated development environment, which is just a text editor that highlights your code and auto indents and all sorts of stuff like that. Makes it easy to write C# code. Forget about the compiler behind the scenes because Unity does not use C# compiled code. C# just happens to be the language that Unity has selected to do their scripting. Okay? They also have an alternative language that's JavaScript, but they could have really picked any language they wanted. Unity internally interprets your scripts, your C# scripts, into the Unity way of doing things. All right? So they've written their own kind of prior to runtime. I don't even know if we want to call it a compiler because they're not running it natively on the CPU. Unity, when Unity creates an executable, when you write your game and you say export for Windows, Unity is going to dump that out as this giant executable that says, here's your game. And that executable is written in terms of all the C# scripting stuff you've written, but it's not using Microsoft's compilers to convert C# into a binary. It just happens to allow you to speak the C# language to Unity for Unity to know what you're asking it to do. Does that make sense? And then it's internally converting it to the Unity way of doing things. All right. So whether you're using Visual Studio, which Unity ships with on Windows now, or you're using Mono Develop, which it comes with for the other ones, but I usually recommend you go ahead and download Microsoft Visual Studio for Mac. I'm not even sure if it's available for Linux. Would assume, well, I don't know what I would assume. 70% chance it is. But it doesn't matter. I would recommend you get that for the Mac as well. I just think it's a better editor at the end of the day than Mono Develop. It more commonly will do command completion and that kind of stuff. Just makes your life a little bit easier. And I'll show you how you can select, change the default from Mono to Visual Studio. It's just one little drop down. So in any case, they just chose C# as the scripting language, not relying on Microsoft's compilers or anything like that. Why do you think they did that? Why do you think they chose C# as their scripting language? In contrast, Unreal Engine uses C++. as their scripting language. And then they also have kind of a newer, what's called a low code environment where you can do drag and drop programming type stuff to accomplish 85% of the stuff you might want to do. Why do you think Unreal chose C++, and why do you think that Unity chose C# as their scripting languages? That coffee is so hot. Right afterwards, I just start chugging it.
More modern, so more younger people are probably going to go C#.
Okay. So Unity being a newer product. Yeah, Unreal Engine's been around for a long time. I don't know when it originally came out. When did the original Unreal first-person shooter come out? A long time ago. Didn't they have 4 or 5 versions of the game? They kept coming out with updates to it. So this has been an evolving engine for a very, 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 very long time. And back then, games were all written in C++. Why is that? Why was C++ kind of the default language to choose back in the early 2000s, let's say? Well, we already talked about a language like Java might have been tossed out the window right off the bat because of how it runs. Java syntax is probably the most important. Java is probably the language, I think, if you do one of those searches of, what are the most popular programming languages out there, Java is usually number 1. I think it continues to be that. So if you become a Java person, a bunch of males in the room, if you become a Java guy, then you probably have the best chance of getting a job. But you probably will not be working in the gaming industry as a Java developer. Even though if you've had Java and you've had C#, you've noticed they're the same language. So moving from one to the other isn't like a major relearn or anything like that. It's possible. Yeah, Python has historically been number 2 on the list. And it's possible you can find lists that flip-flop them, but those are your 2. Actually, your top 3 is always Java, Python, and C#. So pick your order. You'll get a job with any of those 3. There's not like a giant drop off where 98% is Java and then C# holds 1%. We're talking within probably 5 or 10% difference between all of them. So all 3 of those would be good languages to learn, and we teach all of them here. So in any case, why do you think they chose C++ for Unreal? Why was, maybe if we take it a step back, why were older games written natively in C++, whether they used a game engine directly or not? Why do you think they were written in C++? Well, let's think about, how does .NET work? So in this case, we're really comparing C++ versus C# and .NET, right? So, if you go and work for a game company today, and they're writing native games either with their own internal, game engine or physics engine or whatever it is, you're still today probably writing C++. So then we might ask, well, why not C#? Why aren't, if you're a AAA game company, chances are you're targeting Windows as your first platform anyway. You're not worried too much about the Mac and stuff like that, so using .NET isn't a problem. It's your main revenue source is going to be Windows. Why wouldn't you use something like C#? Well, how does .NET actually work? A few minutes ago, we mentioned that .NET languages are technically platform independent as long as you have access to the .NET component architecture, so it'll run on any platform as long as it's Windows. So, but how does .NET actually function? When you have your C# code and you go to compile it, what happens? What actually occurs in there? So I have my C# syntax. And then this runs through the .NET compiler, let's say. What's produced as a result of that? Let's throw C# or C++ in here too. So we have C++. That goes through the C++ compiler. So, it would be CPP, let's say. If you're on a Linux box, it's probably going to be G++, which is the GNU C++ compiler, but whatever. And then what does this produce? This produces we'll just say an exe, an executable, natively running on that architecture. So the C++ compiler converts your C++ code into instructions for the particular processor architecture that you have, the processor architecture matched with the operating system that you're running. So that's the whole life cycle for C++ to exe. C# goes from C# through the .NET compiler. Then it can. Does anybody know what it becomes after this?
DLL file?
No, that would be for drivers and stuff like that. Loadable library. That's kind of your executable. Microsoft Intermediate Language. So this is a low-level language. So they're translating this high-level language into a low-level language, which isn't assembly language. That is, it's not for a particular operating system, it is not the language that goes directly into an executable. Okay, and actually, instead of calling this .NET here, I'm going to call this the CSC C# compiler. All right. So whatever Microsoft's internal name for that compiler is, you typically don't use it externally. You just hit the play button. But in any case, Microsoft Intermediate Language, which then flows into the .NET component architecture, which converts the Microsoft Intermediate Language the very first time you run the application. It converts it into an exe. So the very first time you launch an application, it takes a little bit longer for that application to launch when it's a .NET application, because it's building the exe to run natively on your architecture. So assuming you have a version of .NET that supports your processor and your operating system, that version of .NET will take your Microsoft Intermediate Language and convert it into an executable that will work on your computer. Make sense? And then from that point forward, you have a native executable. It doesn't do the conversion again. So this was really where Java messed up. So if we have Java code went through the Java compiler, JAVAC, which then converted into Java bytecode, which is, a synonym for missile code, right? It's just two different intermediate languages, but they're effectively the same thing, which then went through the Java Virtual Machine, the JVM, which then ran on the CPU. This happened every time you ran your program, that conversion. So slower. You definitely don't want a video game to be translated in real time every single time you run it. This is acceptable up here. If the very first time you launch an application, it takes a little bit longer because it has to build the executable for your platform, and then from that point forward, it's native, it might as well be the exe from up here. Make sense? So we get why Java was not selected as a gaming language. Makes a lot of sense, right? So now we look at the difference between C++ and C#. Now, right off the bat, we mentioned that Unreal Engine has been around for a lot longer. So longer than, to be honest, I don't know if it's been out longer than C# has been out. I don't think it has, or it's at least close. But certainly, it's been out long enough before C# kind of came into its own. Was a popular language. So Unreal chose C++ as their scripting language. C# or Unity chose C#. Now, in both of these cases, as I mentioned before with Unity, they're not actually using the compilers or at least they're not primarily using the compilers for those languages. They just happen to be choosing the C++ syntax or the C# syntax for you to talk to the game engine and tell it what you'd like to see happen. internally, the game engine is going to take your instructions in that language that you and the game engine have agreed upon, or that they forced you into, and it's going to convert it into their way of doing things. That makes sense? So whether we're talking about Unreal or we're talking about Unity, at the end of the day, it's probably converting it into a C++ based executable for both of those applications. They're just deciding which language do we think the largest percentage of our user base likely is familiar with or likely is comfortable with. Right? So in today's world, if we were taken away from computers or something like that, let's say that you're having, I don't know, let's say that's one of these, year-long cruises, that goes to every single country in the world, and you're on the thing for 365 days and stuff like that. Now, most of these cruises are going to repeat stuff in multiple languages, right? But if they had to pick one default language that they were going to make all announcements in, what do you think they'd pick? Probably English, right? Why is that? America. Even though it's probably not even an American cruise line. Like I was just on a river cruise in France, and the main language was English. So they figured, well, you have United States being, let's call it the most affluent country on average. Like what we consider middle class here would be extremely rich in a lot of other countries. So chances are, from a tourism perspective, you're going to have a higher percentage of Americans traveling than folks from other countries. But also, there's a much better chance of folks from other countries to have learned English than it is for Americans to have learned other countries, because we're dumb Americans. Like, well, the only thing worth knowing is English and bad English. Although I always say I'm friends with a lot of my international students. I tell them I'm fluent in their language. When I learn like 2 or 3 phrases in like every language, and I just assume that means I'm fluent. Yeah, so like right now, my current fluency language is Vietnamese. And I've been hanging out with several of our Vietnamese students, and we've been going to this new Vietnamese restaurant in Cedarburg, which is awesome. It's like super good. So I speak to all the people there in Vietnamese, but I only know like 3 or 4 phrases, and none of them are good phrases to know. Like even though you don't speak Vietnamese, I wouldn't record those phrases. Somebody might get a hold of this video. But there's a much higher chance on a cruise ship that your non-American population is going to understand English at least fairly well, right? Significantly better than your American population might understand Mandarin. Okay? So translating that back over to this, even though our internet game developer community now is very much worldwide, right? I mean, I don't know by the numbers. There might be more American developers for games than from other countries, but not necessarily. I mean, I think there's certainly a heavy Chinese population in development, not just game development, but all sorts of software development. Certainly a high Russian population, that make the news every 5 minutes, but there's talent in Russia. They're putting it to other uses. So it's not just Americans writing this stuff. But now we have kind of universal programming languages that all those different folks are speaking, right? That they're fluent in. So now we have to choose what's the core language. So Unreal chose C++ because at that time period, the people that were writing video games were likely fluent in C++. Today, and this is where it becomes a little bit interesting, it still adds a little bit of a question mark on why Unity chose C# as opposed to maybe even sticking with C++, or maybe choosing Java, or even traditional scripting language like Python. They do have JavaScript as an option, but I don't think that typically game developers aren't writing JavaScript stuff unless they are coming from a kind of a web-based game programming side of things, where JavaScript is a kind of a common language. Now, at the end of the day, all these languages are the same, right? They all came from C. So if you knew C or you knew C++, learning C# or learning Java is a 20-minute thing for the starter, and then once you've been working with it for a couple of weeks, now you're fluent in the language. It's not a major jump. All right, but they chose C#, which we might say is a much more modern language than C++. It benefits from some of these bells and whistles that are part of our modern languages. It doesn't make C# better or worse necessarily than C++, but it's almost like, if you think about it in terms of like driving cars, you have, if money was no object, what car would you buy? Something fancy, right? Something fancy and something expensive, if money was no object. And chances are those cars are either, if you're going to be more of a luxury type car, it's going to have all sorts of bells and whistles that aren't requirements for getting to work in the morning, right? Hey, it's like, well, this is, they actually crossbred a cherry and mahogany trees together to produce this, and then they immediately killed it just to produce the woodwork inside of this car. That's not a requirement to get to work, right? But those cars, they have that poshness to them. Similarly, if you go on more of the sports car side of things, you don't need a V10 engine to get to work. Okay, and with the sports cars, you don't need a V10 engine in a car that weighs 50 pounds. It's like, yeah, it goes 0 to 1,000 in 0 seconds. It's not even measurable. So these aren't requirements, but they're nice things to have. So C# relative to C++ is kind of like that luxury car, right? It's not that you can accomplish stuff in C# that you couldn't have accomplished in C++. They just make certain things that you kind of regularly do feel a little bit nicer, a little friendlier, right? That kind of stuff. So if we have our choice today, maybe we choose that a little bit more modern language because, it didn't cost us anything. They're just picking a syntax for you to use to communicate with the game engine. Now, it probably makes sense today for them not to choose C++, because C++ is going to be significantly down that list of languages that are common today. It's not off the list. C++ is still a popular language, but it's not touching the top 3 by any means. Okay, so, but at the end of the day for us, the scripting language, and this is kind of the important aspect of this, from a game engine perspective, that scripting language has nothing to do with the underlying, or at least very, very, very little to do with the underlying performance of that language. Typically, we would say languages like C and C++ are higher performance languages than C#, and certainly higher performance languages than Java. Now, to unpack that last statement, well, not the last statement, but the second to last statement, when I say that C++ is, let's call it, considered to be a higher performance language than C#, when they're both producing EXEs, why is that? Let's just throw out that idea that the very first time you have to run your program, it's getting converted. Who cares, right? Fine, it took an extra 3 seconds the very first time you double click, but from that point forward, we're both operating off of EXEs. Why might we say that C++ is still higher performance than C#? What translates to performance? What is an EXE? Let's start with that. What's an executable on a computer? Don't say DLL again. Although technically that wouldn't be an inaccurate answer. It would be an example of an EXE. It wouldn't tell me what an EXE is. Who eats EXEs? Who reads from EXEs? What's an EXE for?
Applications.
Okay, that's the ultimate thing we're delivering. What part of our computer, what component of our computer?
CPU.
CPU devours EXEs and turns it into the things, right? So an EXE is a list of instructions for our CPU to follow to make awesome stuff happen, right? Okay, so here's a list of instructions. Let's say this is the exact same video game. Okay, exact same video game written in C++ or C#, whether it's a video game application, doesn't matter. All right. They're duplicates of each other, but one was written in C++, one was written in C#. They're both producing a list of instructions for, let's say, the same CPU. Everything's the same except the core language you're using. Now, I'm saying that it's commonly believed, less so today, but still C++ would get the nod today. But historically, C++ would be considered the higher performance language. They would say that this list of instructions is a more optimized way of accomplishing the task than this list of instructions. Okay, they're both lists of instructions using the same low-level language, which then gets linked and assembled into machine code for the code, but that's just a one-to-one translation. So these ultimate instructions translate to exactly one magic trick, as I usually refer to them on the CPU. All right, and it's generally thought of as that this, even though these guys are both accomplishing the same output, the means to an end, this is a more efficient path than this one, or at least likely to be a more efficient path. Why is that? Who produces the EXE? So we know, we've just talked about who eats the EXE, right? The CPU is the one who's processing that and then just, doing its thing, talking to memory, talking to registers, blah, 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 all this stuff. All right, if you're in the 325 class right now, you'd be learning about all that under the hood stuff. Not important for us. This is more of us understanding the kind of the umbrella over this. Who produces this EXE? Oh, we have it in here. So in this one, it's the C++ compiler. And in this one, it's a little bit more convoluted. It's the C# compiler, which converts to missile code first and then goes through .NET, which then produces the list of instructions. So now we're measuring this guy versus this guy. And even though this is a three-stage process, that doesn't necessarily mean it's worse, right? When you get those water filters for at home, the three-stage ones are better than the one-stage ones, right? One-stage ones, still, you don't use those out in like the wilderness. You still get brown water. You use the three-stage ones. You know what I'm talking about, right? More stages better for water purification. But so I'm not sure saying that this one's 3 stages versus 1 stage is necessarily the answer. But point is that this guy here is producing a better EXE. Chances are it's producing a better EXE than these guys here. Why is that? What's a compiler? So those guys are both compilers, right? These 3 steps here ultimately perform the task of a compiler. This one guy here ultimately performs the task of a compiler. What's a compiler? What is that, dude?
Converts high level to low level.
Yeah, so this converts high level code to low level code. Now, that's a pretty easy sentence to write, but is that a pretty complicated task? Yeah, like writing a compiler it's a very interesting job, but it's not going to be kind of fun and rewarding from the perspective of like you're writing a mobile app and you get like some animation working or something like that, right? I mean, compilers are complex things. You're taking somebody's high-level code and trying to convert it into the most optimal low-level code, which can then ultimately get assembled to turn into machine code for the CPU. But there's no optimization there. You have this low-level instruction translates exactly to this magic trick on the CPU. Magic trick 001001111. Whatever. There's a one-to-one conversion. There's no optimization in here. You tell him to do this magic trick, just his easier way of listing that is his machine language instruction number for that. So ultimately, we need to produce that executable, that list of instructions, that list of low-level code in the most optimal way for the CPU to perform this in an optimal way. So if the job of a compiler, generically speaking, is to produce that optimal low-level code, and both of these guys are compilers, this is a compiler, and then these 3 steps put together are a compiler, why might this guy produce a better list of instructions than this guy. Now, we already said that compilers are really difficult things, right? Okay, and they're language dependent. If so when you're writing a compiler for C++, the compiler has to take several things into consideration. So what are the things that a compiler cares about? Whoop. So it cares about the source language. So a compiler is written in terms of the source language. So you'd have a C compiler, C++ compiler, C# compiler, Java compiler, whatever. It also cares about the architecture. So that's talking about the CPU specifically. Is this a third generation Core i7? Because that's going to make a difference between a third generation Core i7 architecture and a seventh generation Core i7 architecture would make a difference. What difference would that make? What's the difference between a third generation Core i7 and a seventh generation Core i7? What might be the difference? Yeah. But what? Well, really. So let's look at this year's Core i7 versus Core i7 from 4 years ago. Clock speed really hasn't changed much.
The amount of cores.
Possibly, but even then, we had quad core 2 or 3 years ago. But maybe. But we're not just buying it for more cores.
It's organized better, like internally, so it's more optimized for the test gets presented.
Possibly, maybe there's some certainly power consumption might be a thing. Okay, we're missing kind of the big one.
Architecture?
Well, you can't just use my word. Yeah, what's the difference between the architectures? Why would somebody buy this year's Core i7 versus last year's Core i7? When they come out and they say, oh, it's this one up to 60% faster than last year's. What are they talking about? What makes something 60% faster than the previous years?
Doing a specific task.
Okay, so what might they have done in this year's Core i7 compared to last year's Core i7 for that one specific task? Add a magic trick?
Yeah.
So this year's Core i7 has more magic tricks on it than last year's Core i7, which has more magic tricks on it than the previous year's Core i7. So on and so forth. They're supersets. Okay. Now, sometimes they might optimize an existing magic trick, things like that. But when your compiler is converting a high-level program from a very specific source language for a specific architecture, it has to only convert to the magic tricks that architecture has. That makes sense? And when a game comes out, for example, and they have that minimum system requirements on the side of the box that says you must have a third generation Core i5 or better CPU, what they're effectively saying is we compiled this for that. And since modern processors are supersets of that, that's the minimum processor you need. Or at least probably need. Sometimes, you'll cheat. You try to use the previous year's Core i5 and see if it works, and maybe it does. Now, if it worked, why did it work? So if it says you need a 6th generation Core i5 and you use a 4th generation Core i5 and it happens to work, what does that tell you about you lucked out, but why did you luck out? What does that tell you about the game?
They didn't use any of the new.
Yeah, they didn't use it. Just so happened that whether they purposely did it when they did the game or not, or when they compiled it, it didn't leverage any of the newer magic tricks. So they just happened to compile it for 5th generation, but it didn't use any magic tricks that weren't also present in 3rd generation. So you kind of lucked out that what you had could respond to all the individual commands that the executable was given. Right? Then you can kind of say, well, let's say they compiled it for a 3rd generation or a 5th generation Core i5, and you're running some old Celeron, like a much, much older processor. Well, let's say just the moons align and it happens to not use anything, earth-shattering new magic tricks or something like that, which is possible. Now you might start running into clock speed issues and some of that. Like, look, my processor is not up to the task of going through these instructions quick enough to run this game at a reasonable rate. Make sense? So these other things play into it. But from our perspective, this architecture that they're compiling for represents the minimum official system requirements, but might not necessarily represent the minimum processor it will run on. That's more of a computer architecture course type of concept. But from our perspective here, what we're talking about is this idea of the compiler, which is saying, here's my source language. Here is my instruction set I have to work with. I need to turn this high-level language into a bunch of instructions that are present in this architecture. Make sense? And then what's the third thing that's important for an executable? So we got the source language. We got the language the CPU speaks, which fancy way of saying is architecture, which makes it sound way more complex, right? Like immediately trying to spit out DLL. It's like it's gotta be some acronym. What's the third thing that's important for executables? Think back to when you've been in one of my classes where I showed you the Hello World program in assembly, which is a low-level language. And even though it looked way scarier than like Hello World would in Python or Java, it didn't look as scary as it could have looked. Why? What did that Hello World program? I'll bring it up. Let's do Linux Hello World. Linux assembly. It's the one I usually use. Yeah. Read that okay? Why could that guy be a lot worse than he is? This is actually written using some power tools, even though it looks like something that's not overly friendly to write. What's happening right on this line? Go ahead.
Isn't like just right like a program that like says this pixel turns on with like this letter and stuff like that? So like it takes the text and just like it's like a program that allows it to display on the screen.
Okay, so we can think of it as a program or a function. Either of them is fine for this example. So right here, this line where we're saying move into this hardware register, the number 4, just randomly the number 4. That 4 represents this program of the operating system, the underlying operating system. So the Linux operating system has a program on it called syswrite. And that program, right off the bat, when it launches, it's going to go and look in EDX, ECX, and EBX for all the information it needs to do its job. These are like the inputs to that function. Okay, so we're going to load the length of the message we're printing. Here's the actual message we're printing, which is hello world. Here's where we're printing it out to, which is the monitor, standard output. So I'm loading those 3 things into these little buckets over here. Then I'm calling, well, actually, I don't, then I'm saying the program I'm going to call is program number 4, which happens to correspond to syswrite. And then right here, I'm calling the kernel. Now, kernel is kind of the scary way of saying calling the operating system, telling the operating system to go and look in this bucket to find out what program you want me to call. Then call that program. That program knows to then look in these 3 buckets to get the inputs it needs to do its job. And then it goes and spits stuff out to the screen, because that's what this program does, is it spits stuff out to the screen. So if we didn't have the operating system who had already provided us this magical tool that knows how to do all the hard work of spitting stuff out to the screen, this code would be a lot longer, right? This is what the executable might look like. This is the step right before the executable, before we do the actual translation to the machine language. This is what that executable would ultimately look like. Each of these instructions is exactly one magic trick that the CPU understands. That makes some sense? So our third piece of information here is what OS are we on? Because that compiler is going to take our source code language. It's going to take our list of instructions the CPU understands, and it's going to take the list of system calls that this operating system supports, including the number for those system calls. Like on Linux, the number 4 is syswrite. On Windows, the equivalent of syswrite might be a different numbered system call. So these are all things that has to take into consideration. So now consider that you're writing that compiler. Like a common compiler, a popular compiler is GCC and G++, which are the GNU compilers for C and for C++. These guys have been around the longest, so chances are they probably support the most number of operating systems and architectures, probably. So if you're writing that compiler, think about all the extra stuff you've had to put in there. Every single time a new architecture comes out, when this year's Intel Core i9 blah, 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 blah processor comes out, you have to then go and look at all the magic tricks that are in there, compared to last year's magic tricks, go and copy all the stuff from last year, or come up with however your compiler is written and say, okay, well, if they chose the architecture of Core i9, newest, latest, greatest, blah, 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 now I brought these new instructions into the equation. Make sense? Now, if you're also so now you've had to amend your compiler to now also work with that newest, latest, greatest architecture, which might not be the architecture that we compile for if you were producing a game that was released, right? If you're writing a video game today, or you're writing a mobile application today for Android or for iOS, and we've seen this for those of you who've had one of the classes where you do Android programming. You start your new project and it says, what API level are you building this for? And it usually picks ice cream sandwich or something like that. Ice cream sandwich. Okay, ice cream sandwich, like API level 17, even though the current API level is much higher than that. And right next to it says what percent of devices that are in circulation today could run this. Because only the most recent. Should I be getting? But it seems like when I'm like screen sharing, I shouldn't get like these. Yeah, whatever. Let's just leave it alone. It could only get worse. So every single time it's also funny that it's just coming up now. So it's also funny that, from a compiler perspective, why do we have every single time a new operating system comes out, every time a new architecture comes out, we have to make these changes? And how often are we actually going to choose the latest, greatest architecture, the latest, greatest operating system when you have a very much smaller number of people that are running that particular processor or that particular architecture or that particular operating system, where you really want to target your larger audience? And then we get back to, you might cut out some magic tricks that you might want to use in your game, for example, or in your application, but you're going to say, I'm not going to leverage that technology because it's only available on the newest, latest, greatest processor, which isn't going to be supported by the largest, a large percentage of my audience. Or you could write your game with different flag set, where if somebody happens to have a particular CPU architecture or a particular version of an operating system, they can take advantage of some special features of your application versus somebody who has an older version who can't take advantage of those things, something like that. Does that make sense? Now, if you're getting down to that granular level, though, now your game design becomes more difficult. Your compiler design becomes more difficult because you're having to make all of these decisions about making everybody happy. And that might be something that a AAA company might do for PC games. This is also one of the reasons why console games for like Xbox and PlayStation are easier to produce. Until recently, with the kind of the pro versions of the two boxes, but even then, it's at least a known enemy, right? But until recently, if you were writing a PlayStation 4 game, you were creating it for the PlayStation 4 hardware, not a moving target. You knew exactly what architecture, you knew exactly what operating system the PlayStation 4 was running. You knew everything. Similarly for the Xbox. So you could create a compiler that's very efficient for those particular things. You could write code that takes advantage of only the magic tricks that are on that particular architecture, so on and so forth. Or if you're on a PC, it's common in video games now on a PC where you have like that menu where you can like run on like ultra graphics or good graphics or black and white flip book. That'd be a really funny option. Line art. Okay, I am running this on a TI-82 graphing calculator. I know it said the minimum system requirements are Windows 10 with at least a Core i7, but I think this can handle it. That reminds me back when I was in high school. I started programming when I was 9, so I'd been programming for a while. And high school, the older Texas Instrument calculators, it was like you were cool if you could program the calculators. Now people like shove you in the lockers, right? Okay, but it used to be cool for doing that. So me and one of my buddies, we wrote an RPG on a Texas Instrument calculator, like a role-playing game. It was called Ghettos and Gangsters or something like drug dealing. It's drug dealing RPG or something. It was pretty funny. I don't know why that popped up, but it just did. All right, so in any case, do we kind of see that moving target that we have? So if you're creating a compiler, it's a really, really, really complex job. So our punchline here is, why is this executable likely better performance than this one? They've been evolving this compiler for a lot longer than they've been evolving this compiler. Now, this guy down here had kind of a jump start, right? He was able to kind of take the latest, greatest compiler technology and stuff like that. But even so, there's been tweaks and stuff like that over the years in this compiler, especially with the GNU version of it, which is open source, because now you have a gigantic community who will go out and look for ways to optimize it, where this guy is closed source. So you only have Microsoft engineers, which are smart people. You just have a smaller group who are looking at how can we optimize that. Make sense? So at the end of the day, any of our game engines today are very likely creating an executable from a C++ compiler. All right, questions, comments, concerns, bribes. All right, so this video will be up. I think the link should work now. Remember, for Tuesday, by midnight Sunday, your Bible homework is due, and we will get into Unity on Tuesday. Have a good weekend, blah, blah, blah. Remember, chapel, 9:30, front row. You're invited. I sit right there in the front. We really belt it out with the hymns. Never get any tape.